Welcome to 4B, which is factoring quadratic trinomials. A lot of this is review. We'll get into some stuff that you may have never seen before. Right away, first example, we are going to be factoring a trinomial whose leading coefficient is 1, meaning in the quadratic form, ax squared plus bx plus c, the leading coefficient, a, is going to be 1. So 1x squared plus 6x plus 8. The leading coefficient here is 1. When this happens, there's a shortcut to factoring. Factors is two things that are multiplied together to come up with that. So we need to have two factors that multiply to get x squared plus 6x plus 8. So when you have a leading coefficient of 1, the easiest thing to do is what two numbers multiplied to 8 that will also add up to the middle number. So what two numbers multiplied to the last term, c, that will also add up to b. So multiply to c and add to b in the quadratic here. So we have what two numbers multiplied to 8 that add up to 6. That's 4 times 2, and then 4 plus 2 adds up to 6. When you have a leading coefficient of 1, you can just break this x squared up into x and x. And then we have a positive 4, so plus 4, and a positive 2, also plus 2. You may be thinking, can I write it this way? X plus 2 times x plus 4. And the answer is yes. By the commutative property of multiplication, you can switch those. So either one is the correct answer for factoring. Moving on. Same thing. Another one, leading coefficient of 1. So it's what two numbers multiply, and take the sign with it, so it's negative 10. That will also add up to negative 3. And we only can do this because we have a leading coefficient of 1. So, the first terms are going to be x in both of the binomials. And we have what two numbers multiply to negative 10. That will add up to negative 3. And that should be negative 5 and 2. No shame in writing all the factors out if you wanted to write negative 10, 1, 1, negative 1 and 10, negative 2 and 5. If you want to write them all out to visually see it, go ahead. But we have negative 5 and 2 that will add up. They will also add up to negative 3. So it does not matter the order. So instead of negative 5, we just write subtract 5. And it's a positive 2, so plus 2. So here's your two binomials that if you multiplied them out, a lot of you know it is spoiled, you will get this trinomial here at the beginning. Moving on, let's skip this problem. Moving on, so now we're going to do leading coefficients that are not 1. So when it's not 1, there's no shortcut, we can't do that. But the process isn't that crazy different, a little bit more to it. So the first thing we do, you look, the a is not 1. The a is going to be 8. And the b is negative 10. And the c is negative 3. First thing you do is a times c. So 8 times negative 3, negative 24. And you're still going to do now, instead of just c, what adds up to b is what two numbers multiply to negative 24, that will also add up to negative 10. So again, let's go through. You have negative 24 and 1, negative 1 and 24, negative 2 and 12, negative 12 and 2, negative 6 and 4, negative 4 and 6. Do any of these pair of numbers, do any of them add up to negative 10? So we're looking for negative 10. And looks like right here, negative 12 and 2. So now I have this Punnett square over here. You do not have to use Punnett square, but it's kind of a nice, neat little organizer. So the Punnett square, we never use this top little square over here. But in the middle square here, we put the first term. In the last square in the bottom right, we put the last term. And then the two numbers that we came up with here, those two go in the diagonal. It does not matter the order. And since it's negative 12 plus 2 is negative 10, we're not actually looking for negative 12 and negative 2. we want them to add up to negative 10x. So it would be a negative 12x and 2x. So now what you do, and it does not matter the order you put these in. These can be in, you can put them negative 12x down bottom and 2x up above. It does not matter. So now we're looking for the greatest common factor, so the GCF of each term, or each row and each column. Bottom row, the greatest common factor is 1. The top row, the greatest common factor is 4 and x. The first column, the greatest common factor between 8x and 2x is 2x. The last column, the greatest common factor is 3. Since both of them are negative, we're going to take it as a negative 3. Now, you should always look back and to make sure that everything works out. So the opposite way, if you do 2x times 4x, you should get 8x to the squared. So this is Punnett squared. So you have 2x times 1 is 2x. Negative 3 times 1 is negative 3. So everything lines up. So this is good. Our factors are here. 2x minus 3 and 4x, and the 1's positive. So this would be 2x minus 3 and 4x plus 1. So I'm just going to run through a problem again. Try to make this a little quicker. You do first term times the last term. And so what two numbers multiply to negative 42 that add up to negative 19? It just so happens to be negative 21 and 2. So we put negative 21 and 2. And since the middle term has an x on it, we're going to put x on both of these. So the first term goes in the middle spot. The last term goes in the last bottom right. Take your greatest common factor out, bottom row, 1. Top row is 3x. First column, 2x. Last column, 7. And since both are negative, take a negative. Let's make sure they all line up. 2x times 3x is 6x squared. 2x times 1 is 2x. 7 times 3x, or negative 7 times 3x is negative 21x. And negative 7 times 1 is negative 7. Good, they line up. So that means we have this right. So 2x minus 7, that's one of your factors. 3x and plus 1. Yeah. So now we're factoring, we have two variables. Not anything crazy hard. You're still looking, this first term, the a, is still 1. So we're going to do this exact same way. So the leading coefficient of 1, let's look at the last term. Let's see. That's 4, positive 4. What two numbers multiply to 4 that'll add up to negative 5? Hopefully you're telling yourself it's negative 4 and negative 1. Negative 4 and negative 1 multiplied to positive 4, and they add up to negative 5. So now we have to worry about these variables, though. First term is x squared, so that's still going to be x and x. But now this last term is y squared. So what you do is you just put y on the end. So we can clean this up a little. Instead of minus 1y, we can just use subtract y. But there are the two factors. So here again, we can do this the exact same way you just did it before. This one has two variables, but now we don't have a leading coefficient of 1. It's 2, so we have to do a times c, so the first term times the last. One adds up to the middle. And that's negative 6 and negative 1. If you're having troubles with this, doing this in your head, I will show you a way to do this on a calculator. So don't worry too much. First term goes in the middle. Last term goes on the end. Middle term, we have negative 6, negative 1. So we have xy. So on the negative 6 and negative 1, we're going to put xy. Because it has to add up to the middle term total. So you have the first, or bottom row, looks like the greatest common factor is y. The top row, greatest common factor is 2x. First column, the greatest common factor is x. Last column, the greatest common factor is 3y. And you're telling yourself, Mr. Johnson, when we multiply this out, we get 2x times x, that's 2x squared good, but 2x times 3y is positive 6xy. Uh-oh, I'm seeing problems. Sometimes if you see a negative, if you see negatives on both of these here, these also, the greatest common factors are going to be negatives. So if you take x times negative y, it's negative 1xy. Negative y times negative 3 is a positive 3y. 2x times negative 3y is a negative 6xy, so now we're good. So sometimes you do have to play around with it, positives and negatives, but only when the only thing I've ever seen is when these are both diagonals here are negatives. So we have 2x minus y left. There's your greatest common factor. So we have a difference of two squares. So here's the general formula, a squared minus b squared. Anytime you see something like this, you can just break it up into a plus b and a minus b. This is similar to the very first problem. This is also a shortcut. So you see, if you can see the first term, you can square root it, and the last term you can square root, and there has to be a subtraction. Has to be a subtraction. If it's not a subtraction, this does not work. So if you can square root the first term and square root the last term, we can just break this up into x plus 9 and x minus 9. And those are the factors. So this is a special case. Speeds it up. Let's do it again. Here we have square root of 25x squared, 5x square root of 144. 12y, and there is a subtraction, so we can do this. 5x, 12y, 5x, 12y, and you put one with plus, one with minus. It does not matter which one it is. One's plus, one's minus, and that is factoring the difference of two squares. Alright, that will be good enough for today. Come to class with any questions you have on these. We might do more factoring in class, but hopefully this was a good review for you and some of the new stuff. But hopefully you learned something from this. Have a good one.